Have you ever wondered where electrical power goes after it leaves the transformer? Many people think it goes directly to the main distribution board. But that's not how an industrial electrical system works. The first stop is usually the Power Control Center, or PCC. You can think of the PCC as the heart of the entire low-voltage electrical system. Every kilowatt of power entering the plant passes through this panel before it is distributed to other electrical panels or large loads. We'll explore each section one by one. By the end of this video, you'll understand not only what a PCC is, but also why it is one of the most important panels in any industrial facility. What is a PCC? Let's start with the first section. A power control center receives electrical power from the distribution transformer. Its job is not only to distribute power. It also protects the electrical system, monitors important electrical values, and provides a safe point for switching and isolation. In most industrial plants, every major electrical panel receives its power from the PCC. Without this panel, safe and reliable power distribution would not be possible. Now let's move to the next section. The main functions of a power control center. Although a PCC looks like a single electrical panel, it actually performs several important jobs at the same time. The first function is power distribution. Electrical power enters the PCC from the transformer and is distributed to different panels and large electrical loads throughout the facility. The second function is system protection. If a short circuit or overload occurs, the protection system detects the fault and disconnects the affected circuit before serious damage can happen. The third function is power monitoring. Engineers can continuously monitor voltage, current, power, frequency, energy consumption, and power factor from this panel. The fourth function is safe isolation. Before maintenance begins, circuits can be isolated safely to protect personnel and equipment. In other words, the PCC is not just a distribution panel. It is also the control and protection center of the entire low-voltage electrical system. Now, let's open the PCC and see what's inside. At first glance, it may look like a large metal cabinet. But inside, every component has a specific purpose. Let's start from the top. This is the air circuit breaker, or ACB. It is the main incoming breaker of the panel. Its job is to protect the entire low-voltage system against overloads and short circuits. When a serious fault occurs, the air circuit breaker disconnects the incoming power to prevent damage to equipment. Next, we have the copper bus bars. Think of the bus bars as electrical highways. Instead of carrying power through many cables, the bus bars distribute large amounts of current safely and efficiently throughout the panel. Now look at these current transformers, also called CTS. These devices do not carry the load directly. Instead, they measure high current and convert it into a small, standardized current for meters and protection relays. Without current transformers, accurate measurement and reliable protection would not be possible. Next is the digital power meter. This device continuously measures important electrical values such as voltage, current, frequency, active power, reactive power, apparent power, energy consumption, and power factor. Engineers use this information to monitor the health and performance of the electrical system. Finally, we have the outgoing feeders. Each feeder supplies electrical power to another panel, a motor control center, or a large industrial load. Together, these components allow the PCC to distribute power safely, monitor system conditions, and protect the entire electrical installation. Now that we know the main components, let's see how the power control center actually works. Imagine that electrical power has just left the distribution transformer. Where does it go first? It enters the power control center through the incoming cable. The first device it meets is the air circuit breaker, or ACB. Think of the air circuit breaker as the main gate of the entire electrical system. As long as this breaker is closed, electrical power can enter the panel. If a serious fault occurs, this breaker opens immediately and disconnects the incoming power. After passing through the air circuit breaker, the electrical power reaches the copper bus bars. These bus bars distribute power evenly to every outgoing circuit inside the panel. At the same time, the current transformers measure the current flowing through the system. The measured values are sent to the protection relays and the digital power meter. This allows engineers to monitor the electrical system continuously without interrupting the power supply. Finally, the electrical power leaves the PCC through the outgoing feeders. Each feeder supplies another electrical panel, a motor control center, or a large industrial load. So the path is simple. Transformer. Air circuit breaker. Bus bars. Current transformers. Outgoing feeders, and finally, the electrical loads. Every second, this process happens automatically and continuously. Now let's look at the single-line diagram. A single-line diagram is a simplified drawing of an electrical power system. Instead of showing every wire, it uses standard electrical symbols to represent the equipment and the power flow. This makes the system much easier to understand. In this diagram, power enters from the transformer. It passes through the incoming breaker and reaches the main bus bars. From there, the power is divided into several outgoing feeders. Each feeder supplies a different electrical panel or a different section of the plant. Although the drawing looks simple, it contains all the essential information needed to understand how power is distributed. That is why every electrical engineer should know how to read a single-line diagram. Now let's talk about the advantages of using a power control center. The first advantage is centralized power distribution. Instead of connecting every load directly to the transformer, the PCC organizes the entire electrical system from one location. The second advantage is better protection. Modern protection devices can quickly detect electrical faults and disconnect the faulty circuit before serious damage occurs. Another important advantage is continuous monitoring. Engineers can monitor voltage, current, power, energy consumption, and power factor in real time. A well-designed PCC also makes maintenance much easier. Since all major switching devices are installed in one panel, troubleshooting becomes faster and safer. Finally, a PCC improves the overall reliability of the electrical system and reduces unexpected downtime. Where are power control centers used? Almost everywhere. You'll find PCC panels in manufacturing plants, oil and gas facilities, water treatment plants, hospitals, data centers, commercial buildings, mining sites, and power stations. Any facility that requires safe and reliable low-voltage power distribution is likely to have at least one PCC. In large industrial plants, there may be several PCC panels working together to supply different sections of the facility. Before we finish, let's quickly review the main components inside a PCC. The air circuit breaker protects the incoming power. The copper bus bars distribute electrical current. The current transformers measure current for protection and metering. The digital power meter monitors the electrical system. And the outgoing feeders deliver power to other electrical panels and industrial loads. Together, these components form the heart of the low-voltage distribution system. Before opening a PCC, always make sure the panel is properly isolated and all safety procedures have been followed. Never rely only on the position of a circuit breaker. Always verify the absence of voltage using an approved test instrument. Regularly inspect bus bar joints, cable terminations, and ventilation openings. Thermal inspections can identify loose connections before they become dangerous. Remember, most electrical failures don't happen suddenly. They usually begin as small problems that are ignored over time.